Ndugu wapenzi watazamaji, ninawakaribisheni wote katika chaneli yangu ambayo inajulikana Mnoka Official Channel. Lakini siku ya leo kuna project mpya ambayo nimeandaa. Inapatikana katika somo la physics. Topic moja inajulikana current electricity. Katika topic hiyo ningependa kujifunza jinsi gani tunaweza kupata current endapo unakuwa umepewa resistor ambazo zinakuwa be connected in a parallel way. So siku ya leo ningependa tukaangalia jinsi gani tunaweza kupata current katika branch tofauti tofauti. Hiyo basi nipende kukaribisheni tujifunze pamoja. Let's go. Wapenzi watazamaji, siku ya leo nimekuja na project mpya ya kutafuta current endapo umepewa circuit yako ikiwa katika mfumo wa parallel way. Hivyo basi tutatumia law moja ambayo inaitwa ni current division law. Current division law. Hii law ndio itatupa mwongozo wa kutafuta current ukiwa umepewa circuit ambayo imeunganishwa katika mfumo wa parallel way. Hivyo basi current division law means this law deals with the distribution of electric current when the resistors are connected in parallel connection. Haya ndio maelezo ambayo yanaelezea law yetu ambayo tumeandika hapo juu. Sheria hii itatusaidia kupata current tofauti tofauti pindi tu circuit yako inakuwa be connected katika mfumo wa design yako. Hivyo basi tuna kesi mbili katika law hii. Kesi ya kwanza inaitwa consider two resistors connected in parallel connection as the figure shown below. This one. Yeah. This is the simple circuit which show the resistance being connected in parallel connection. So through this circuit we'll find many currents from this circuit. And in this circuit, we have two branches. The first branch is this one, and the second branch is this one. The first branch will allow current 1, and the second branch will allow current 2. And this one is the total current passing through this circuit from this potential difference across A to B. Means the direction of current is from positive to negative. Means in this way. That is. From there, let R be the total distance of R1 and R2 in the parallel connection. And V, let's be the potential difference across AB. I mean this one, here to this one. This is potential difference across this and this. So, because of that, the effective resistance is obtained by this way. 1 over R means the reciprocal of this one equals to 1 over R1 plus 1 over R2. This one is in terms of the reciprocal way. Also, can be shown in this way. Effective resistance equals to the product of R1 and R2 over the sum of R1 and then R2. That is the total resistance of this circuit. That is. Thereafter, you might recall the Ohm's law. From Ohm's law, we know that V equals to the current flowing through the circuit times effective resistance. But we've seen that effective resistance is the product of R1 and R2 over sum of R1 and R2. Since V is in each resistor are equal, then R1 is given as V over R1, since we find the current passing only in this resistor. But V will remain constant because the potential difference across in parallel connection are equal throughout the circulation. But V equals I times the product of R1 and R2 over the sum of R1 and R2. Yeah, substitute V in this equation. We find that I1 equals to I is total current passing through the circuit times product of I1, R1 and R2 over sum of R1 plus R2, but over this one. By making cancellation, we find that this one will go with this one. Thereafter, we remain with this question, or this formula. R2 over the sum of R1 plus R2 times the current, or total current. Thereafter, I1 is current passing through the first resistor, this one, is given by taking this formula. This one. By taking R2 over the sum of R1 plus R2 times current total. Similar, if you are guided to find the current passing through resistor 2, also might be shown this way. I2 equals V over R2. But remember, V is constant throughout the what? The resistor. Thereafter, I2 equals product of R1 and R2 over the sum of R1 plus R2 times current total over R2. By making cancellation, we find that R2 and this one will cancel out and remain with this one. Is A2 equals R1 over sum of R1 plus R2 times total current. That is. So we've seen the first case when you have been given two resistors which are being connected in parallel connection. So how can you find the current which we have more than two resistors? We see in case 2. That is, in the last time we've seen that how current can be formed when you have given two resistors which are being connected in a parallel connection. So, but now let us consider when the circuit have more than 2 branches. Is this circuit shown below. Under this circuit, you may find that we have 3 resistors which are in parallel connection. So, how can you find the current? Which path through the resistance? From above, we find that our total current is given as I1 plus I2 plus I3. Means I1 will pass in this way, and I2 will pass in this way, and I3 will pass in this way, respectively. And this one means total current. And this one means the potential difference across these 3 resistors. From this one point to this point. From this formula, we find that I equals to V over R1 plus V over R2 plus V over R3. Meaning that V over R1 means I1, this one, and V over R2 means I2, this one, and V over R3, this implies I3. Also, I as a total current is given as V as potential difference times effective resistance, which are given in a reciprocal way. 1 over R1 plus 1 over R2 plus 1 over R3. But also, this one must be shown this way. R equals to V over sum of R2, R3 plus R1, R3 plus product of R2 and R3 over product of 3 resistance, mean R1, R2 and R3. Then recall V equals to I1 times R1 equals to R2 times R2 equals to R3 times R3. Since we know V is constant whenever the resistance are in parallel connection, V remain constant. That's why I've shown in this way. Now, to get I1, how can you get I1? Means current pass through resistor 1. From above there, we have seen that V equals to I1 plus R1 but also R equals to V over R1 of V over I total, R total, where R is effective resistance. It is known. Then, to get I1 means current path through R1. It is found this way. I equals to V over R. but he called that this one, this one, this one, this one, but to be this one is from here. If you remember, but this one is effectively distance, which can be shown in this way. Therefore, to get I1, here, we take and know this one is a fraction, and also it is overcancelling. So we find that I1 will cancel with this I1 and will be with this one, which is this one. Since our demand is to get I1, hence this one will shift to this one, and this one will be over this one. Therefore, I1 will remain is shown below here. Similarly, we may use this way to get I2. Is as shown from this way. I2 equals product of I1 and I3 over the sum of two products. This one, I1, product of I1 and 2 plus I2 and 3 plus I1 and 3. And so, but also to get I3 is like this one, but the main concept is from here. By using this concept, we find the distance, the current of each distance whenever the circuit are in more than 3 branches. So my lesson today is this one, which I have introduced to you. So you may take the time yourself and pass through this. I think that you can get something. Thank you. Nichukua fursa hii kuwashukuru wadau wote ambao tulikuwa pamoja katika kipindi cha physics practice. Hivyo basi, wale wote ambao mmefuatilia channel yangu mwanzo mpaka mwisho, kumbuka kushare, kulike, kusubscribe channel hii ili wa kwanza kabisa kujipatia vipengele vijavyo. Pia nipende kumshukuru mdau wangu mkubwa kabisa ambaye daily ananifanya kwamba nionekane, project zangu zionekane. Si mwingine ni master moja anajulikana, Mr. Manase Ali. Shout sana zimfikie, heko sana zimfikie, kwa sababu ndio yeye ananifanya kwamba nionekane kile tu leo. Sambamba na hivyo, nipende kuchukua fursa hii kuwashukuru wazazi wangu ambao of course wanisupport katika namna moja au nyingine, kwa kunipa muda, mawazo, hata katika swala zima la kifedha. Na wakaribisheni sana. Asanteni sana.